Well, let's talk right now with Jay Kamath. It is 8:30 p.m. where he is. He had nothing better to do on a Friday night than come hang out with us. And people have been waiting, as Ms. Gates said. So tell us, please, about your forced oscillation technology. Now, you're beyond prototype, yes?
Yeah.
Okay.
So, you can hear me, right? Am I good?
As long as you lean into the camera, yes. When you're back there, it's a little harder.
Okay. So, good morning. I'm assuming everybody is out there in the. I have to say only good morning. Nobody.
Yeah, at the moment, yeah. I don't think, unless Mark is in Europe right now. Oh, May is. It's afternoon for May.
Okay. So, this is the pulmonary function test device (PFT) designed now marketed by us in India. We have 3 models out there. The first one is what we call basic. It uses oscillometry technology. So we'll talk about it. What's oscillometry? Little bit of background. As you know, PFT is currently spirometry is used, as a golden standard for lung function test. So spirometry has come with different sizes, shapes, and but ultimately one has to breathe very hard into it. It's because lung volume based. So it's purely depend on patient effort. He or she has to breathe. So it becomes often challenging for children, geriatric population, just to breathe into that device. Hence, what happens is you will not get the actual results. So diagnosis becomes to that extent difficult. So, here is the technology that is oscillometry, which is used for the same reason, lung function, diagnosis. So it's a non-invasive technique. It does the mechanical analysis of the respiratory system. So what happens in oscillometry is it directly reflects on the condition of the airways, because the way it works is it has got built-in. Can you see my screen? Okay, so as we speak, yeah. Mm-hmm. Okay, because it's based on a tidal breathing principle. So one has to breathe the way we are breathing. And it addresses primarily whatever shortfall of spirometry, although it gives a different set of readings. So the readings that we see in FOT oscillometry are totally different compared to what you get in spirometry. Nevertheless, you can compare, based on the situation. So just for everybody's information, PFT device is used primarily for both what we call obstruction, lung obstruction, as well as restriction device. So obstruction, what I mean is asthma, COPD, and those kind of which are primarily I'm not able to breathe. There is obstruction in the lung pipe, so that's why it's called obstruction. So where is the actual obstruction happening is something that we get to know in this device. Whereas restricted device as ILD, what we call, for example, where we are unable to breathe, the lung sacs are, I'm unable to. I'm not able to hold the entire the way I breathe. This is called restrictive. So both of these devices, PFT is used to diagnose this. Just for everybody's information. And what we have done is, of course, FOT is not new. This technology is out there for many, many years. Okay. Based on our information, information that we have, we are the 5th one in the world to come out with the oscillometry technology for lung diagnosis. And first one in India that we know. Okay, in India, we are the first ones. And last 4 years, we have been working on this technology. And thanks to COVID, we lost almost 1.5 years. Nevertheless, we continue with our design and development of this. We have done 3 clinical trials in India. All are done in India as per Indian regulatory requirement through different hospitals. And we have recently partnered with Cipla. Cipla is an India-based MNC in pharmaceutical company. So they are into pharma, and they are our go-to-market. They have taken distribution for India. So and we have sold as of now 90 units in India. Okay, that's where we are, and we are coming out with the variants of this product. So just to cater to affordable market or low cost market that we call for this part of the world. And in terms of accuracy and predictability, etc. So we have done the analysis comparison with the Canadian company called Thoracis. You must have heard of Thoracis. The product called TremoFlow. So we have done apple-to-apple comparison with this device, and results are pretty close. So I will show you some of those findings. So I'm sure all of you know about spirometer, and the major problem or drawback in spirometer is it requires hard maneuver while breathing, which is what we are trying to solve in oscillometry in our device. So let us talk a little bit of principle of this. How does it work? In case of oscillometry, we are creating oscillations. The oscillations can be either a sinusoidal oscillation or it can be a square wave. Okay, both ways it works. One is called FOT, other one is called impulse oscillator, what we call. So both are okay. So we create external oscillations, okay, and that gets superimposed on the tidal breathing. So we created oscillation, and these oscillations are then bombarded into lung pipe, and the frequency is between 5 hertz to 20 to 40 hertz. Why I said 5 hertz is the low frequency, and 20 hertz is what our first device gives, up to 20 hertz. The next gen, the Antlia Plus, the second one, which is under validation now, that gives up to 40 hertz, okay, which is the industry benchmark so far. So between 5 hertz and 40 hertz, the continuous oscillations are fed in a sequence, and whatever I get back from the lung pipe, that gets diagnosed using sensors, which is what we measured. So and these oscillation signals should be of certain volume and what we call. It has to meet the requirements of American Thoracic Society or ERS, European Respiratory Society. So there are guidelines given how it should be generated, how it should be, so we have complied with those guidelines, by the way. So if you look at the 5 hertz, that's the first frequency that we generate, that gets up to alveoli. It goes faster into the up to alveoli, and which is what we measure in response as impedance. So what we measure is impedance, and as you know, impedance has 2 components. One is resistance, the other one is reactance. So which is what we measure in this, and the 20 hertz, that higher frequency component, it only goes up to the upper airways. So which is what we measure at 20, and the difference is what we R5 minus R20 or Z5 minus Z20, which is what gets it's calculated, which measures the in between obstruction. So that's how the simple measurement is done. So here you can see the graph. In the normal for you and me, okay, assuming, so for you and me, so when I breathe into the device, both resistance and reactance, whatever sinusoidal wave is generated, bombarded into my system, the same thing gets reflected because there's no obstruction. If I am an asthma patient or COPD or any of that, then my resistance, which is shown as red, it gets elevated. That means there is some obstruction happening. Likewise, the reactance part, which is the imaginary part of Z, also gets, as you see here in the colored area, it gets highlighted, which means both resistor as well as imagine that reactance part, there is some, it measures the obstruction. And on the right hand side, we have shown here, this is what we measured. We measured the resistance at 5 hertz, 20 hertz, and so on. Okay, and the area under the curve, the rectangle that triangle that you see, AX, the lesser the AX, which is good, which shows healthy. The more the AX, it shows there is some problem either, depending upon asthma, COPD. So there is a calculation there. So these algorithms we have developed, and which is what we have filed patent also in India. So which is what the key principle of operation in case of oscillometry. Let me show you a small demo just to get an idea how it works, what we are doing. Any questions at this point?
I see no hands up at the moment.
Am I okay with my speed? Are you okay with my speed?
Yeah, I am. Okay. Everyone all right?
But this is a device. Okay. Yeah, I'm just showing the device. Okay. On the front end, you put that filter, which is a disposable, and the patient has to use that in every device. And there is a laptop or desktop or mobile phone or smartphone, anything, which is a user interface where patient data gets, patient information, all that gets recorded. And
hey Jay,
once you record,
sorry?
Yeah.
Hey Jay, we only see the presentation slide. Are you sharing a video or an image?
Oh.
Yeah, we just see demo in number 6. Are you attempting to show a video? Or are you going to show us something and you just have that as a placeholder?
Yeah. I think I'm not, 1 minute.
Marvin Barron, are you growing a mustache? Is that what's happening? You're on mute, but maybe that's for the best.
It's the love in this place that keeps me coming back.
Well, we like your goatee.
Can you see the screen
Yes.
now? Okay. This is the device. And in the front, this is where patient has to breathe. We have the BVF filter, what we call that bacteria white filter. And here is a laptop that is shown, which is the user interface screen, where patient data has to be fed, patient details. And once you feed all the details, because we need to measure BMI, here comes the next screen, where there are 2 conditions, patient, either pre-bronchodilator or post. So one has to make those entries. And what we measure is, you can see the volume and the pressure, which is what gets measured as the patient breathes. So patient has to put the mouthpiece and the nose clip. He has to sit straight, and he has to just breathe the way we breathe, what we call tidal breathing. All you have to do is do the breathing. Once you can see the screens, those pressure waveforms coming. So once the patient is comfortable, then I press capture button. Here then starts the that capture. So one has to breathe into this system for about 30 seconds. So here in this, I bombard 5 hertz, 15 hertz, 20 hertz, up to 40 hertz, depending upon adult or pediatric. I bombard that continuously for about 30 seconds, and test is over. That's all required. Once the test is complete, you will see the report on the screen. As per European Respiratory Society guidelines, one has to do the breathing 3 times. Because one has to do the breathing 3 times. I'm coming back to my screen now. And the average of those 3 readings, or good of those 3 readings, is what gets populated.
Jay, I'm gonna ask you to put the video back on, because that was very clear for us to see what it is you're working on. And I suspect while that runs, someone in the audience will have a comment or a question about its design and functionality. I'm looking at you, Jan and Rick. I'm imagining that you guys have thoughts and commentary.
I've got a quick question. Where's the sensor? And are you actually measuring the echoes?
1 minute, yeah, just let me get the demo back.
Yeah, I was
Just
just
a-
looking at that arm and how that would ship, but I don't know about the rest.
I don't know what's going on with Cartoon Nelly down there.
It's a new thing they let you do on Zoom now or Teams or whatever. It gives you a avatar.
Okay, now she's smiling. Well,
Where
that's,
you, where you can always look your best.
Yes.
I've seen her look better. And that's not even an insult. That's actually a compliment.
Hey, I've got the cats and dogs fighting over here. I was trying not to be distracted. I've got literally, they're like jumping like beans behind me.
Would entertain anyhow, but yeah, I think that's the first time I've ever said, I've seen her look better, and it'd be a compliment.
I don't know. Who thinks it's a compliment? Everybody raise your hand.
Okay, back to business. So if you would,
Yeah.
show the video again. and
So
we'll
this is
do-
the, I'm just running the video.
Yeah.
So here is the, what I call upper portion, what we call F40 tube, is a tube. Here are the sensors. We have two sensors, pressure sensor and flow sensor. So these sensor, and here is where I breathe. And this portion, can you see? I'm sure you can see.
Yeah, yes.
That's where you have the sound waves being.
Yeah, this is
Generated.
where we generate those sound waves, 5 to 40 hertz.
Are there any disposable parts with this?
Yes, there is one filter, which is a filter. Every patient has to change that. I'll show you that.
Jay, are you in stealth mode? I mean, when I share this, is that okay? Do you want people to see what you're working on? Have you got strategic?
Yeah, can you see this filter? He's putting the filter. Can you see that?
Yes.
This is the disposable. And so as the nose clip. Both these touch patient, so both are disposable.
I was asking if you're being public about this, have you spoken with strategics to partner with? Are you looking for?
We have
people to
shown this,
become aware?
yes.
Andre, you had a comment?
Yes, thanks, Joe. Just a question, because we worked on a device for peak measurement and using a pneumotac for measurement on spirometer. I'm just wondering, since you're not asking the patient to exhale to a maximum and so forth, and you're just taking normal respirations, doesn't that become variable because the patient can vary it between your tests? They could just, increase their flow or inflow or outflow because they're just sitting there breathing.
So this is different from spirometer, if I've understood your question.
Okay.
Okay, here I generate sound waves, frequency 5 hertz to 40 hertz. And
Right.
this gets superimposed into patient breathing. As a patient, I'm supposed to do the normal breathing, what we call tidal breathing for 30 seconds. During 30 seconds, my generator pressure, it gets between 5 hertz and 40 hertz, I bombard the continuous sinusoidal waves. And I have two sensors there. If there is an obstruction anywhere in the lung pipe, it gets recorded. Either upper airways or up to alveoli. So that's the principle of operation.
Continue
so-
the video so we can see the waves again. Look
So
at
with the tidal breathing, so are you instructing the patient to just be sure they breathe normally?
Exactly.
Okay, understood.
Can you measure the lung volume?
We do not measure, we are not measuring this. Yeah, this is impedance based. So I'm sending sinusoidal waves and I measure the impedance, which has got resistance and reactance part.
Jay, would you go with the video where we can see the screen of how what you're measuring there?
See, while the patient is breathing, I'm capturing the volume and pressure of the sound waves. All I'm doing, measuring the volume as well as the pressure. And based on this, I'm deriving those impedance, resistance reactance.
So is this device an addition to a spirometer or would it replace it?
Yeah, we think that eventually this will replace spirometer.
Okay,
But
so.
as of now, spirometry is the gold standard throughout the world.
Right.
Okay, and if you want to replace it, why wouldn't the pulmonologist need the lung volume?
What we are doing is today, what we are doing, at least in here, the doctors, because they're used to, the pulmonologists are used to spirometer. So we are giving them spirometer and plus this, so that they get, they can compare the result.
So it's not going to replace it, but complement it.
Currently, it is complementing. Yes, that's correct.
So
Because there's a lot
permanent-
of what is that teaching and understanding this technology requires.
I know
We
that,
believe, yeah.
I'm sorry,
Right.
you're based out of India and you've made a low cost device because reimbursement is not a thing in India. As an American, and I'm thinking about the American system, you're introducing a cost. Do we have reason to believe that patient outcomes will be improved with the addition of this? Because it sounds as though your primary benefit is making it easier on the patient, which is great. But I'm thinking about introducing a cost into the system with no patient, no improvement potentially in patient outcomes, no reduction in cost, and introducing something operationally that people have to figure out. That sounds like it violates all three principles: clinical, operational, and financial.
Okay, so what the benefits, if you have to see, compared to spirometer, is children and geriatric, they just can't breathe into a spirometer. So
But
we are able to.
if I may, you say they can't, but you also say that spirometry is the gold standard. There's no alternative. So are you saying that those patients are simply not being measured, or they're doing it but not as well as if they had this?
There is no proper diagnosis, accurate diagnosis with spirometer. At least here, that's the case. So diagnosis become, because then, unless you breathe your lung volume out entire, it's very difficult to capture those conditions, right? Because spirometer is based on lung volume based. Principle is different. So there's a challenge we are facing. Hence, we are trying to address that.
Goldie?
Yeah, it's interesting technology, but I had a similar question, Joe, that you just asked. From the presentation, it wasn't clear which patient population and what clinical benefit. So I heard asthma, I heard pediatrics, I heard, young, maybe young patient. I don't know what the age group is, if it's a pediatric or adolescents or something else. It would be really, for first-time listener, right? It would be really good to know the problem statement and the impact, patient benefit impact that technology makes. And it didn't come across to me. So that's my comment.
Dan?
Yeah, I'm looking at this and it seems like you would have to have a before and after making sure you understand the obstruction or not that's going on in somebody's lungs. So if I look at a practical use, I take my sister, she had lung cancer and they used a spirometer to find out how her lung volume was. So when they took a lobe out of her lung, they knew what was going to happen and if she could survive that, and then how to exercise her lungs later with a spirometer. And I don't see how this would be helpful at all.
Okay, so some of the applications are mentioned over here. Can you see my screen now?
But
Yeah.
how do you know? Do you have a standard based on body type or something for lungs? Because I don't understand how you can tell there's an obstruction when you haven't measured them in the first place when they were decent, had good lung capacity.
Yeah, so here what we do is we measure, as I said, we measure the impedance, lung impedance. We convert it as a resistive network. when there is a resistor network, as I said, it has got both resistance and reactance. For me, for a normal healthy, whatever impedance that's bombarded in my pipe, I respond to it. So there is no obstruction. And when I send the, we are following the principle of sinusoidal wave from 5 Hertz to 30 Hertz, which is proven. There are enough papers out there that shows lower frequency, it goes up to the alveoli. And higher frequency, that's 20 Hertz and above, goes up to the upper airways.
But you got to have a number, excuse me, a number to start with on what's normal.
There are cutoff values given for healthy volunteer. Depending upon the age, there are cutoff values for these resistance and reactances provided. So there are normal values given. Anything out of this is considered as abnormal.
Okay, and so your normal is based on a sample size of what?
We have sample size considered as 300 adults.
And do we know if it's different in India versus a polluted place like the US and Chicago?
We do not have the information from US, but we have compared this with European data. It compares well. So we have published a report, so I can share that. Yeah.
So that helps. I'm trying to make sure I understand what you've got here. And I think it's neat. I love the idea of sound waves going in there, but I just don't understand how you check obstruction versus normal. So I guess I'd have to see obstructions. And that's what you're trying to show here?
Yeah.
Sleep apnea happens at night. Are they breathing into this tube at night?
It is possible. We can connect this. We have done this experiment. So this can be connected in parallel with sleep apnea, and you can measure the impedance.
Billy is working on something in sleep apnea. I'm hoping he comes on as a panelist. I invited him. Perhaps he has a comment there.
I have a comment on that, Jay.
Oh, yes, of course, Michael is too.
Yeah, so the later ResMed devices actually do this as well, but they actually do it with air pressure. So they do micro air pressure pulsations. Yes, I think it's square, on, off, etc. They identify whether or not your sleep apnea is obstructive or central. If you stop breathing about 4 or 5 seconds into usage, you'll actually breathe these puffs. I actually stopped using the ResMed devices because of that. And I went to a different device because it actually wakes up people who have sleep apnea. I'm sorry, central sleep apnea, or it prevents them from going back to sleep. Some technology like this, if it's using sound waves going down the tube, could be very beneficial to like Philips, ResMed, Fisher Paykel.
Okay, just for information, Mike, ResMed has shown interest in our device.
Exactly. Makes sense.
With whom are you speaking there, Jay?
Local guys in India.
Okay.
The marketing team, basically.
Sanjeev, you are from where? Where were you born and raised?
So I was born in India and left India very early in my life, but the first 15 years I was in India. But one of my companies I was doing in India in between 2004 and 2011, and I can see in the Indian context and Africa, etc., this would make a lot of sense, especially when you consider cost, because those are cost-sensitive markets. Besides, and I actually worked on COPD with inhaler spacer technology. So I see what you're talking about, Jay, out here. It makes sense. And we would talk about blowing into that. And it was really hard for kids to blow into it. Whenever you talk to kids or, geriatric patients, you tell them to blow. My father had Alzheimer's, and you tell him to blow, he wouldn't be able to, right? And so someone who's got Alzheimer's, dementia, I think this would be phenomenal for them because now you're just measuring sound waves, right? So that's a little feedback.
Well, I'm intrigued. I know so little about the Indian market. I just basically understand that reimbursement's not a thing. And
No, it's just not reimbursement, Joe. It's also an issue with not having enough physicians. And if you can make it easier for the healthcare provider, be it, it may not be a physician, it may be a nurse or someone, to do this work and get the physicians the information, that's going to be, that's important. And so healthcare in India is not just the way we do it, but you
Right.
got Ayurvedic and you got homeopathic medications, etc. Right? And there,
I was texting Gunjan. I hoped he could jump on. He has a conflict. Because I'm thinking about this with an American brain, and as we said earlier.
yeah, Gunjan is actually in a meeting right now with my brother, so that's how I know.
Is that right?
Yeah.
It's your fault he's not on. That's very funny. Is that how, did you jump on because he told you that I texted him?
No, no. I've been on the, when I read what you were going to be, Jay was going to be talking about. So this is something I want to listen.
Okay. Well,
because I'd worked on COPD with the spaces, so this was pretty interesting.
I'm very, apologies to the rest of the world with my US centric brain. I'm wondering if Jay's concept would work in America. Do you think it would? Because before you joined the call, we were talking about clinical, operational, and financial.
I think it would. I mean, Joe, if you look at what I'm doing, when people look at that, they say, hey, the venture community says, hey, it's ideal for India and Africa, etc. But there are other advantages for the US market and the European market. And I think those are things to talk about. Now, if Jay, you talk about it in the context of, like I mentioned, Alzheimer's, and that's a big thing in the US, right? It's bigger out here than anywhere else. It's going to make a difference. You talk about Parkinson's, you talk about these other diseases where, it's hard for people to blow into it. Or let's say someone's got, my brother-in-law just went through surgery for oral cancer, and it's hard for him to open his mouth completely and blow and stuff like that. Now, people with these kind of things, it would be easier if you have sound waves going and they have to just breathe normally. So I think you have to look at it in the context out here and see how to position it out here, right? But it would be pretty interesting to have something like this. My father had a cardiac surgery, and they asked him to use, to breathe, and he had a tough time because he also had the onset of Alzheimer's. And so now you start talking about these geriatric patients who are in their 70s and 80s and who are starting to get Alzheimer's or dementia. I think this would be phenomenal for them.
Thank you. Mark with a C.
Yes, sir. I just have one question. How hard would it be to add blood volume, lung volume, so you could replace the spirometer to the device?
It's possible.
Because I would think that if you would have a device where, that's what the pulmonologists are really used to measuring and looking at and what they're tracking. And so if they could use your device instead of the device they're using now, and it would give them and have all these other advantages of being able to work with more patients, I would think that would be persuasive.
Sure, Mark. Noted.
Mark with a K.
Yeah, I think we were thinking along the same lines, because I was saying if this is going to be
Marks.
marks of excellence. If
Very nice. You've used that before.
I've practiced it. If you have this as a separate device, complementary to spirometry, then my question would be, Jay, have you done any kind of clinical market research to find out exactly what the percentage of people is that have these kind of problems medically that would need that?
Yeah, so what we have done is, at least in Indian context, first of all, there is any obstruct lung related issues are not at all getting diagnosed here. Okay, so that's where we are. That's the, from there we have come a long way, understanding, asking them to breathe into something like this, because the moment they see spirometer, they run away.
Is that a
So
large
with this-
percentage? Is that a large percentage, or is that, I mean, I'm large as, I guess theoretical. What can you even put in numbers to, the percentage of people that would need this, the type of people who have problems? Do we have any kind of statistics on that whatsoever to see?
Around
where
the
this
30
falls
to 35% mark.
Ooh, that's a lot. And that's just India. That's just India, right?
We are right now only in India. What we have done is an entire research we gave to Dr. Sandeep Salvi, who is clinical research. He does only research. So these are his findings. I will share some of those, his findings, which is published with you with this forum. So you will know.
Okay, well, that's a pretty big number. It'd be interesting
Yeah.
to see what kind of numbers we get in Europe and the United States and Australia and Japan, because obviously this is something that could go worldwide. And then, yeah, what Mark just said too, if you can include spirometry, then you've got something that not only does spirometry what everybody's using, it does it better, because now you can capture that full 35% and everybody else. So you've got literally 100% of the market then, right?
Mm-hmm. It's a good point. Yeah.
Thank you.
And being a packaging person, how much shipping have you done with this thing? Because that arm looks pretty fragile for shipping.
We have installed 19, it's 90 in India.
I'm not following you.
And
What?
she's asking if you were to mass produce this, you need to ship it. What packaging tests, drop tests and the like? Jan, you're gonna have the stage, I think, in.
We have done IEC drop test, 1 meter drop test, all that we have done. Is that what the question?
Yeah, that's what she's asking, I think.
Okay.
Yeah, and vibration and everything else that goes with it.
Yes.
Yeah, because that arm looks a little fragile for shipping. So it depends
Yeah,
on what you're putting in.
Yeah, that's right. So the one which I showed you is the next generation. I mean, the one which you are already producing is a different model. So this is under validation right now.
Yeah, the nice thing about it is that even if the arm were damaged or probably even broken, you could still use the device.
Wow.
Sorry about that. That was my phone.
You don't want to send his broken device.
It could, I mean, if I had one of these at home and I was using it to monitor like I would use a blood pressure device, and the arm somehow became broken, I could literally just hold it up to my face and use it that way.
So
It's not ideal, but as a failure mode, it's
the
not
marks of
serious.
excellence kind of theme. We're gonna continue on with undamaged product on the door.
Ideally.
Ray, you have a comment? And I'm glad to call on you. I rarely see your hand raised.
Yeah, hello from UK. So I just want to follow up on other people's comments and recommendations. So in the UK and in the EU, we go through the health technology assessment pathway. I think the PICO method is a good way to use. You define the population, the intervention, the comparator, and also the outcome. And it's good to put the FOT in the clinical decision cascade. So even it's used together with the spirometry, it might be used as the first device, but to confirm the diagnostic, then you need other measures. But it gives you a way to compare the cost, and maybe when you go to other markets, you can use that data to show the cost effectiveness. That's my comment.
Thank you,
Yeah.
Thank you.
Sure. So, some of our, there are two predicate devices, which are both are US FDA 510(k) approved. So, one is Respon Pro, one is Canadian thoracis. And as per FDA, it is called in one case diagnostic spirometer, and in other case respiratory impedance measurement device.
Michael, you have something?
Yeah, just a quick question on your list of applications. One thing I've heard is it can be challenged is trachea stenosis. Is this something that can help there, and have you looked into that?
I didn't get your question. I'm sorry.
Oh, I'm wondering on that list of applications, I didn't see trachea stenosis, and I'm wondering if this is something that could help there.
Here, okay.
Yeah, can this help trachea stenosis, where your trachea collapses due to various things like intubation and things like that? Can this help identify if you have a shrinking of a trachea to help identify that condition?
Got you.
It was a bit difficult to, Michael, you have a colleague in your office, I think, and he's providing interference. We didn't really get your comment.
Okay, let me try again.
Or you could type it in
this-
chat if we're unable to. get it.
Sure, well, I'll type it in chat.
Okay, thanks. Billy, you wrote me a comment. Can I call you out and have you share with the class?
I think I wrote a lot of comments. Which one are you talking about?
You wrote me about bronchoscopy and about breathing capacity and.
So I'm just trying to think about how this might fit into the normal physician workflow and
in the US.
In the US again, right? Which again might be completely different than what you're looking at, but since I'm sitting in the US, that's how I'm thinking.
And he also considered an FDA submission strategy, so he is thinking about the US.
Well, right, and so here you need to think about how this fits into the physician workflow and how they're going to get reimbursed for these things. And the more steps you add, and the more costs you add, if they're not getting paid for anything, they're not getting any more data, any better ways to make patient diagnoses. It's going to get killed very quickly. And so you need to look at how they're normally diagnosing things like obstructions right now, and whether they're just doing bronchoscopies and things like that, where they're getting reimbursed for those already. So if you end up taking away some of these procedures, again, the physicians might push back against something like this.
Sure. So I'm told that spirometers are reimbursed, those in the US.
They are,
Okay.
but I mean, it'd be interesting if Nick were on, because I don't, really to what Billy's point and what I was saying earlier, again, the US brain, I'm not understanding the incremental benefit to the population that's already being served. You might be able to argue that more people could have appropriate tests, given that you can get the youth and the geriatrics. Golda, you have a comment on this thing?
Yeah, so I started with patient population and clinical benefit, and I think May also touched on that. Even if you have a 510(k) clearance, I just read the intended use very generic. Coverage is usually looking for more data and very specific to clinical condition, clinical benefit. So your patient population has to be very, very well defined, and the data should support that population that you're benefiting. So I would say from the US market perspective, having a CPT code existing, you may use it, but coverage may not be there, right? Because how you present information. So great. I think the idea is great. The technology is doing really, it's a non-invasive way of measuring something. You are averaging it out over three data sets. Very quick. So analysis is going to be, a report produced. They can look at the numbers and they can take whatever clinical action they need to take. But before you go to that level, you need to really show which population will benefit from it, because you have multiple things going here. So your data needs to be very specific. Is it sleep apnea? Then what kind of a population you study? If it is a pediatric, there is a range of pediatric from 0 to 21. Which one are you studying? Is it relevant population for the US? So I think great technology, but there's a lot to think about. How do you really approach which market section and what coverage would you get?
It's interesting in that context. Michael contributed in the chat. Have you looked into identifying tracheal stenosis? There's so many things you can do and so many intended uses and applications that, you know, streamlining could be helpful. I'm curious, Jay, when you agreed to share with us today, and I'm grateful for that. What did you think you would hear? Like, have the beauty of these conversations, why I enjoy them so much, especially ones like these, where you're showing your work and we have multiple disciplines looking at it, you know, from their own perspective. What did you think you might have heard? Did you hear anything you didn't expect or get a perspective that you hadn't considered? I'm interested in your feedback from this hour.
Okay, so my okay, when you asked me to present this, my idea was, is this something except in the US? Because I don't know US market. I mean,
And what have you heard? Have you heard yes or no, or?
What I heard, what I understood is, you know, it is not the way we are looking at this part of the world. The US is different. So I would really go down, drill deep, dig deep into the use case part of it. Fair enough. That's a very valid input I got from this forum.
And team, are there things that you heard that's like, oh, Joe, please get me in touch with Jay because I can help him with X, Y, or Z? Perhaps not, but that's certainly an option for you all. If you have an idea, that's really the spirit of the conversation. I'm curious, tell me about your company name. Does it mean something?
iCalTech Innovations.
I'm sorry, A-N-T, oh, no, A-N-T-L-I-A. What, does it have a meaning?
There's a product name, yeah, that's the branding.
Yes, of course. How did you come up with
that? Means pump.
Oh, it's a known brand?
Yes.
So are you like, is iCalTech an accelerator for Indian companies?
iCalTech is name of my company.
Yes, and your company is an outsourced team that you could bring on to help you develop your product. So, and Tilia has contracted iCalTech to help them bring this to market. Is that the way you work?
Antler is my product name, brand name.
Yes, but it's yours.
iCalTech is my company name. Both are ours.
Oh, okay.
Yeah.
And does Anthea have products in market already?
Yes.
And what products do you have on market already?
Right now, these are respiratory devices we are marketing in India.
But beyond this, I'm asking about, do you have like revenue elsewhere that's helping fund this development, or are you still looking for investors and you're not cash flow positive?
I have another firm called Caliber Assurance Services. In Caliber, we provide design services as a service.
I see.
We work with Philips, Siemens, Medtronic. So they outsource the design work to us in India.
Okay.
Primarily India focused.
So you're a pretty big deal.
We have 70-member team.
Good for you. Well, I remember you blessed me in 2015 when you came to 10X, my first one in San Diego, and you were part of a panel. And I recall we had a gal from the former Soviet Union, and we had a fellow in from Germany, we had an Australian, we had a Finnish woman, and you, and we all talked about how you go about developing things. I still have that video. I should republish it.
Great, Joe. You're fantastic.
I am fantastic. We got that on video. I'm gonna take just this little piece of the video and I'm gonna feature that on my timeline. Joe, you are fantastic. And I'm gonna play it in a loop.
it's the same. And that is the only 10x I attended, Joe. I could, afterwards.
We'll
Maybe
see if
next
we
year,
can
definitely
catch
I'll
you.
make it.
We'll make plans for 2024.
Yes, yes.
Thank you.
Now the
Next-
question to the audience, should
Yeah.
I go for FDA 510K now, or I have to wait to sort out this use case?
I think Goldie's the best to answer that.
I think having a 510K strategy is a different thing. Having a coverage strategy is a business decision, and you are having a predicate. So that's not going to change. You are going to have a same codes that those predicates are using most likely. I don't know exact details of how different you are from a workflow perspective, but coverage you should really consider now. As a business, if you want to be in the US, you need to really figure it out. Coverage very specific to patient population.
Drop off. I'm sorry, but I really wanted to get his perspective as a fellow Indian developing products in the US. How would you answer, Jay? Would you encourage him to spend time and resources now looking into the US, or focus on his market now and worry about that later?
I think he should look at his current market and understand the US market before he applies, before Jay, you apply for US FDA.
So you would discourage him from spending too much time and resources on the US at this point?
At this point, I think it's important to consolidate your India strategy and everything. And then in the meantime, understand how you want to position it in the US and then apply for the FDA approval.
I'm inclined to go with that perspective as well. Do we have anyone saying to the contrary?
Yeah, I think that if you really need to collect data in the US for US patient population, having a 510K under your belt will help you. Otherwise, you will be treated as an investigational device, which is very expensive way to collect data. So if you need to figure it out, what data would you need for coverage? And if you have a 510K, you collecting data as a real world data will be cheaper than investigational data.
May I put the two of you together so you can continue the conversation offline?
He's connected with me on LinkedIn. So
yeah, you found one another. Good.
Yeah, no, it's a great technology, but strategy is important, right? So yeah, I may talk to Sanjeev also, because we think differently, and it's always to how you navigate this. It's a complex area, right? And little things matter.
Again, one of the things that bring me such joy on these Fridays, that you're thinking of things I just never would have thought of, and I hope I add some value there as well. Next week, 10X alum from this year, Brian Meshkin, you'll recall, is the CEO from Prove Biosciences, and he had the story of how he fought the DOJ who came after him in his FDA raid and audit and such. And he's emerged from the fire, and he's now getting funding for 2 companies in the next couple of weeks. So I've moved things around. He's going to present next week. You may be interested as investors, certainly as fellow technicians in the medical device arena. So I hope you can join us for that.
Or just as fans too. I mean, that's all that presentation.
As fans, and
he was amazing.
Of pain.
Yeah, and he's a great speaker.
Yeah, he's a lovely, lovely man. So if you can make it, please do. And Jay, thank you for sharing today. Thank you everyone for joining, and thanks for being the highlight of my week.
Thanks, Joe.
Thank
Thanks
you
for the opportunity, Joe. Really appreciate it.
Thank you.
Goodbye.
Thank you. Bye.